The most powerful bite force ever measured belongs to the saltwater crocodile, 3,700 pounds of crushing power. But T-Rex? It could chomp down with over twice that force. And those famous teeth, each one was self-sharpening, serrated like a knife, and could regrow in just months. But what's really interesting? This apex predator's lethal weaponry tells us something completely unexpected about how it hunted. But before we dive into T-Rex's hunting secrets, we need to go back to 1902, when a discovery in Montana would change our understanding of prehistoric life forever. In 1902, paleontology underwent a seismic shift when Barnum Brown, a fossil hunter for the American Museum of Natural History, made a remarkable discovery in Montana's Hell Creek Formation. Brown and his team, including Yale paleontologist Richard Lull, unearthed a set of bones that would soon become the subject of intense scientific scrutiny and debate. The find was fortuitous, occurring shortly after they had set up camp, and Brown later remarked on the mix of joy and envy he felt at their quick success. The excavation presented significant challenges. Only about 10% of the skeleton was recovered, making the task of piecing together this ancient predator a complex puzzle. Early 20th century paleontological techniques were everything other than advanced compared to modern-day technology, relying on manual labor and basic tools. Each fragile bone had to be carefully extracted, cleaned, and documented. Adding to the complexity was a previous misclassification by paleontologist Edward Cope. In 1892, Cope had attributed 2 partial vertebrae to a different dinosaur species, which would later complicate the process of identifying Brown's discovery. Despite these obstacles, the team persevered. The bones were transported to the American Museum of Natural History for further study. Henry Fairfield Osborn, the museum's president, took on the task of analyzing and describing the new species. In 1905, after extensive research and comparison with other known dinosaur fossils, Osborn published his findings. He named the species Tyrannosaurus rex, meaning king of the tyrant lizards. This name would capture the imagination of both scientists and the public, perfectly encapsulating the fearsome nature of this prehistoric predator. Osborn's report was groundbreaking, including a detailed description of the fossil's anatomy and laying the foundation for future studies of theropod dinosaurs. The T-Rex skeleton discovered by Brown became the holotype specimen, the single specimen designated as the name-bearing representative of the new species. The unveiling of T-Rex marked a pivotal moment in paleontology. It advanced our understanding of dinosaur evolution and ignited public fascination with prehistoric life. But the real shock came when scientists began measuring just how massive this predator truly was. What they found would challenge everything we thought we knew about land-based carnivores. Barnum Brown's discovery of Tyrannosaurus rex was just the beginning. As more specimens emerged, scientists faced a fascinating question. How large could this tyrant lizard king really grow? T-Rex stood as one of the largest land predators in Earth's history, with fully grown adults reaching lengths of up to 40 feet or 12 meters and heights of 12 to 13 feet or 3.5 to 4 meters at the hip. To visualize this, imagine a beast that could easily peer into a second-story window, or a predator nearly as long as a school bus. The skull of the T-Rex was particularly impressive. The largest known T-Rex skull, named Maximus, measures an incredible 6.6 feet or 2 meters from snout to back, longer than many humans are tall. This massive cranium housed an array of about 60 teeth, each capable of protruding as far as 6 inches or 15 centimeters. And these weren't just oversized fangs, they were precision instruments of predation, complete with serrated edges designed for gripping and slicing through flesh. Despite its enormous size, T-Rex wasn't slow, or that's what scientists used to think. The speed of T-Rex is something that has been discussed back and forth for decades. Some studies suggest it could achieve running speeds of approximately 10 to 25 miles per hour or 16 to 40 kilometers per hour, which is an impressive feat for an animal of its proportions. But the most recent study, based on the best preserved fossil trackways and study of its biomechanics, suggests something much different from the other studies. Because of its big size and the stress caused on its bones, T-Rex would only achieve a speed of around 3 to 6 miles per hour or 4 to 10 kilometers per hour when walking, and 10 miles per hour or 16 kilometers per hour when running. These physical attributes only scratch the surface of what made T-Rex such an effective predator. Its massive size and powerful jaws were part of a complex array of adaptations that allowed it to dominate its prehistoric ecosystem. From its keen senses to its rapid growth rate, every aspect of T-Rex's biology played a role in its success as the apex predator of its time. Determining the size and capabilities of creatures extinct for 66 million years requires a combination of detective work and advanced scientific techniques. When dealing with incomplete fossils, paleontologists use methods like comparative anatomy to analyze the structure and proportions of known bones, inferring the dimensions of missing parts to create a complete picture of the animal's size and shape. Yet size alone doesn't explain how T-Rex dominated its world. Hidden in its massive skull was a secret weapon that would make modern predators look like amateurs. We've all seen those massive jaws in museums and movies, but the reality of T-Rex's bite was even more extraordinary than most people imagine. This ancient predator possessed a secret weapon hidden within its mouth that would make modern carnivores pale in comparison. The skull of Tyrannosaurus rex was a masterpiece of evolutionary engineering. With a length of up to about 4.3 feet or 1.3 meters, it housed an array of up to 60 teeth, each protruding as far as 15 centimeters. These weren't just oversized fangs, they were precision instruments of predation. Serrated and sharp, these teeth were perfectly designed for piercing and gripping flesh, making T-Rex one of the most efficient predators in Earth's history. What's even more remarkable is the rate at which T-Rex could replace these formidable weapons. Unlike humans, who get just 2 sets of teeth in a lifetime, T-Rex continuously shed and regrew its teeth. Studies suggest that T-Rex replaced its teeth approximately every 250 days. This rapid replacement ensured that the dinosaur always had a fresh set of razor-sharp teeth at its disposal. The biomechanics of T-Rex's bite were equally impressive. Its lower jaw featured a joint that may have absorbed shock from struggling prey, enhancing its ability to capture and consume large animals. This adaptation, combined with its thick skull bones and strong bracing, allowed T-Rex to withstand the immense forces generated during powerful bites. To put this into perspective, imagine a Nile crocodile's bite force multiplied by 2. That's the kind of power T-Rex could generate. Interestingly, T-Rex's teeth morphology evolved as it aged. Juveniles had up to 74 narrow teeth, while adults had fewer but larger and more robust teeth. This shift indicates a change in feeding strategy as T-Rex grew, possibly moving from smaller, faster prey to larger, more challenging targets. As we piece together these incredible features, the size and number of teeth, the rapid replacement rate, the specialized jaw structure, and the evolving tooth morphology, we begin to understand why T-Rex was such a formidable predator. Its bite wasn't just powerful, it was a precision tool capable of delivering crushing blows and intricate cuts with equal ease. While its bite force was unprecedented, there's one feature of T-Rex that seems to make no sense at all: those infamously tiny arms. But new research suggests we've been completely wrong about their true purpose. Picture a T-Rex in your mind. Now zoom in on those infamously small arms. They seem almost useless, don't they? But these tiny limbs could potentially lift more weight than you. The answer lies in a fascinating quirk of dinosaur anatomy. The contrast between T-Rex's massive body and its comparatively tiny forelimbs is striking. While the dinosaur could grow up to 40 feet or 12 meters long and 12 feet or 3.5 to 4 meters tall, its arms were only about 3 feet or 0.9 meters long, roughly the size of a human arm. This disparity has puzzled scientists for decades and sparked numerous theories about their function. Scientists have proposed several hypotheses about the role of T-Rex's arms. Some suggest they may have evolved to be smaller to prevent the dinosaur from becoming top-heavy as its head grew larger. Others propose they could have been used for close-quarters combat or social displays. The truth, as it often is in paleontology, is likely more complex than any single explanation. To understand the potential uses of these arms, we need to look closer at their structure. Despite their small size, T-Rex's forelimbs were powerfully muscled and ended in two mobile fingers with large claws. This suggests they had some functional purpose, even if it wasn't immediately obvious. The bone structure of T-Rex's arms indicates a strong musculature, which could have allowed for significant force application. However, the arms were too short to reach the mouth or grasp prey effectively, ruling out some of the more obvious predatory functions. Recent studies have provided some intriguing possibilities for the arm's purpose. Fossil evidence suggests that T-Rex's arms could have been used for social displays or as pelvic claspers during mating. This indicates a potential role beyond predation, showing that even seemingly vestigial features can serve important biological functions. But perhaps the most surprising revelation about T-Rex's arms is the sheer strength. Despite their small size, a hypothesis made by two paleontologists after an analysis of its arms suggests they could potentially lift up to 400 pounds or 180 kilograms. That's more than many humans can lift with both arms. This incredible strength suggests that while the arms may have been small, they were far from useless. The trend towards smaller arms in some theropod lineages suggests a broader evolutionary pattern, possibly related to changes in hunting strategies or other behaviors. This pattern serves as a reminder for the complexity of evolution. Features that might seem unnecessary or even comical to us often served important functions for the organisms that possessed them. Those powerful but puzzling arms were just one piece of the puzzle. What really set T-Rex apart was something far more sophisticated, a suite of senses that made it nature's perfect hunting machine. T-Rex's sensory capabilities were far more refined than previously thought, challenging our understanding of prehistoric life. Recent research has revealed that this 40-foot or 12-meter-long predator possessed a sophisticated array of senses that made it a highly adapted hunter. Examining fossilized brain casts has led to startling discoveries about T-Rex's cognitive abilities. Its relatively large brain suggests it was capable of more complex behaviors than once believed. The brain structure itself provides crucial insights into T-Rex's hunting prowess. A significant portion of T-Rex's brain was dedicated to processing smells, a trait common among predatory animals. This enhanced olfactory ability would have been crucial for detecting prey from great distances. T-Rex's eyes, positioned forward on its skull, provided excellent depth perception and binocular vision, invaluable for judging distances while hunting. Even T-Rex's ears were finely tuned hunting instruments. Analysis of its inner ear structure suggests it could hear low-frequency sounds particularly well, allowing it to detect the movements of prey or communicate with other T-Rex individuals over long distances. These advanced sensory capabilities allowed T-Rex to detect prey from afar, track it accurately, and time its attacks with precision. During a hunt, T-Rex could have first detected prey through its acute sense of smell, even if the animal was hidden from view. As it approached, its keen eyesight would have helped it navigate the terrain and judge the distance to its target. Its ability to hear low-frequency sounds might have alerted it to the movements of large prey animals trying to escape. The revelation of T-Rex's sensory abilities suggests that the Cretaceous landscape was a complex ecosystem where predators and prey engaged in sophisticated interactions. These keen senses weren't just useful for hunting, they likely played a crucial role in T-Rex's overall behavior and social interactions. To fully understand how T-Rex dominated its ecosystem, we need to examine its specific hunting strategies and the prey it pursued. The combination of its powerful physique and refined senses made T-Rex a formidable predator, adapted to thrive in the challenging environment of the Late Cretaceous period. But even with these incredible adaptations, T-Rex's hunting strategy would surprise modern scientists. Recent discoveries have revealed something unexpected about how this apex predator actually secured its meals. Fossil evidence provides compelling insights into T-Rex's hunting and scavenging behaviors. Coprolites, which are fossilized animal poop, and bite marks on other dinosaur bones reveal a voracious carnivore capable of taking down large herbivores like Triceratops and Edmontosaurus. However, these same fossils also indicate that T-Rex wasn't above scavenging when the opportunity presented itself. T-Rex's hunting strategy likely evolved as it matured. Juvenile T-Rexes, with their more numerous and narrow teeth, might have pursued smaller, faster prey. As they grew and their jaws became more powerful, they could tackle larger herbivores. This adaptability and feeding habits probably contributed to T-Rex's success as an apex predator. The late Cretaceous ecosystem that T-Rex inhabited was teeming with potential food sources. Large herbivores provided substantial meals, while smaller dinosaurs and other animals likely rounded out its diet. This diverse range of prey items highlights T-Rex's adaptability as a predator. T-Rex's massive size, while intimidating, also meant it required large amounts of food to sustain itself. This need for constant sustenance may have driven T-Rex to become an opportunistic feeder, taking advantage of both live prey and carrion as circumstances allowed. Like many modern predators, T-Rex probably took advantage of easy meals when available. Scavenging would have been an energy-efficient way to supplement its diet, especially for a creature of such massive proportions. These hunting behaviors didn't develop in isolation. T-Rex evolved in a world that would seem alien to us today, a landscape where every adaptation meant the difference between survival and extinction. T-Rex inhabited a world vastly different from the one we know today. Instead of a barren wasteland, its domain was a lush, steamy landscape reminiscent of a Louisiana floodplain. This was the Late Cretaceous, about 66 million years ago, when Earth's climate and geography were radically different. The areas where T-Rex fossils are commonly found, Montana, South Dakota, and Alberta, Canada, were part of an island continent called Laramidia. This landmass teemed with life, from towering conifers and newly evolved flowering plants to a diverse array of insects, mammals, and other dinosaurs. The flora of the Late Cretaceous combined the familiar with the alien. Conifers and cycads shared space with flowering plants just beginning their evolutionary journey. This diverse plant life provided ample food for herbivorous dinosaurs, which in turn sustained predators like T-Rex. The atmosphere T-Rex breathed was oxygen-rich, potentially supporting the enormous sizes achieved by many late Cretaceous animals and possibly giving T-Rex and its prey additional stamina for intense predator-prey interactions. Recent studies have revealed that late Cretaceous ecosystems were more dynamic and complex than previously thought. Evidence suggests intricate interactions among species, including predation, competition, and even potential social behaviors among dinosaurs. T-Rex was part of a rich, interconnected web of life. The late Cretaceous saw an explosion of dinosaur species, with T-Rex sharing its habitat with iconic creatures like Triceratops and Edmontosaurus. Mammals, though still small, were diversifying and carving out their own niches. The skies were filled with pterosaurs and early birds, while the seas teemed with mosasaurs and other marine reptiles. This rich ecosystem supported not just T-Rex, but an entire family of tyrannosaurs. From smaller, earlier forms to the giant apex predators of the late Cretaceous, the Tyrannosaur lineage was a testament to the evolutionary opportunities provided by this unique prehistoric world. But T-Rex wasn't always the supreme ruler of this prehistoric world. Its rise to power is a story of evolutionary innovation that would reshape an entire continent. The evolutionary journey of tyrannosaurs is a tale of remarkable transformations. These dinosaurs first appeared around 167 million years ago during the Middle Jurassic period as small, agile predators vastly different from the massive carnivores we associate with the group today. For millions of years, tyrannosaurs played a secondary role to larger predators like Allosaurus and Megalosaurus. About 80 million years ago, tyrannosaurs began to grow significantly larger, coinciding with the disappearance of other large predators. This created an ecological opportunity that tyrannosaurs were perfectly positioned to exploit. As they grew, they developed several key adaptations that would establish their place as apex predators. One crucial adaptation was their powerful bite. T-Rex and its close relatives evolved incredibly strong jaw muscles and robust teeth capable of crushing bone. This allowed them to access nutritious bone marrow and exploit food sources that other predators couldn't. Their skulls also became reinforced to withstand the immense forces generated by their bite. Another important development was their keen sense of smell. Tyrannosaurs evolved large olfactory bulbs, the part of the brain which is responsible for processing scents. This enhanced sense of smell would have been invaluable for detecting prey and potential carrion over long distances. As tyrannosaurs diversified and spread across the northern hemisphere, they evolved into a variety of forms adapted to different environments and prey. Some, like Nanoxaurus, were relatively small, adapted to the harsh Arctic environments of ancient Alaska. Others, like Daspletosaurus, were mid-sized predators that coexisted with their larger cousins. T-Rex itself likely evolved in western North America around 68 million years ago. Recent studies suggest that its immediate ancestors may have migrated from Asia across a temporary land bridge known as Beringia. This connection, formed by lower sea levels, allowed for the exchange of species between Asia and North America. One of the closest known relatives of T-Rex was Tarbosaurus, an Asian tyrannosaur that lived around the same time. The similarities between these two giants highlight the close evolutionary relationship between North American and Asian tyrannosaurs. Despite their success, tyrannosaurs were not invincible. Recent studies have revealed that T-Rex and its relatives underwent significant morphological changes throughout their existence. Some paleontologists have even proposed that T-Rex should be divided into 3 separate species based on variations in femurs and teeth, though this idea remains controversial. The Tyrannosaur family tree is a testament to the power of evolution and the ever-changing nature of life on Earth. For millions of years, these predators adapted and thrived, becoming one of the most successful groups of carnivorous dinosaurs. T-Rex's reign seemed unstoppable, but something was coming that even this mighty predator couldn't fight. An apocalyptic event that would change Earth forever. The reign of T-Rex came to a sudden and catastrophic end 66 million years ago, marking the culmination of events that would reshape life on Earth forever. This wasn't a Hollywood disaster movie, it was the beginning of the end for T-Rex and countless other species. While the cause of this mass extinction has been debated, evidence points to a massive asteroid impact. The Chicxulub crater buried beneath the Yucatan Peninsula in Mexico stands as a testament to this cataclysmic event. The impact unleashed a series of catastrophic effects that made survival nearly impossible for most large animals, including T-Rex. The scale and speed of the extinction were unprecedented. Approximately 3/4 of all plant and animal species on Earth, including all non-avian dinosaurs, disappeared in what amounts to the blink of an eye in geological terms. T-Rex, despite its size and power, was no match for this global catastrophe. The fossil record shows that T-Rex lived right up until the end of the Cretaceous, with the last known species dating to around 66 million years ago. This timing coincides perfectly with the Chicxulub impact, suggesting that T-Rex met its demise along with the rest of the non-avian dinosaurs in the aftermath of the asteroid strike. The disappearance of the dinosaurs opened up new ecological niches, paving the way for the rise of mammals and eventually leading to the evolution of our own species. Though T-Rex's rule ended 66 million years ago, its legacy was just beginning. The discovery of its remains would capture humanity's imagination and revolutionize our understanding of life itself. While T-Rex may no longer roam the Earth, its impact on our culture remains profound. This prehistoric predator has transformed from a pile of bones to a global icon that captivates millions. When Barnum Brown first unearthed T-Rex fossils in 1902, the creature's eventual superstar status was unimaginable. Early depictions portrayed it as a lumbering, tail-dragging beast, more akin to a giant lizard than the dynamic hunter we now recognize. These early misconceptions, however, did little to dampen public fascination with the king of the tyrant lizards. As paleontology advanced, so did our understanding of T-Rex. New discoveries and technologies allowed scientists to piece together a more accurate picture of this ancient predator. We now know T-Rex was likely big in size and pretty slow compared to other animals. But mixed together with its powerful senses, including an acute sense of smell and binocular vision, we can now paint a picture of a sophisticated hunter. T-Rex's influence extends far beyond scientific circles. Its iconic status has inspired unique cultural references, from the memorable roar in Jurassic Park to its appearance in Gary Larson's The Far Side cartoons. These diverse portrayals have helped shape public perception of the dinosaur, often blending scientific fact with artistic interpretation. The ongoing research into T-Rex continues to yield surprising results, challenging our assumptions and deepening our appreciation for this ancient predator. Recent studies have revealed complex behaviors, potential social structures, and even evidence of possible cannibalism among T-Rex populations. These findings not only reshape our understanding of T-Rex, but also provide valuable insights into the broader ecosystem of the Late Cretaceous period. As new technologies emerge, our ability to study T-Rex continues to evolve. Advanced imaging techniques allow scientists to examine fossils in unprecedented detail, while computer modeling helps reconstruct how T-Rex moved and interacted with its environment. Each new discovery adds another piece to the puzzle, bringing us closer to a complete understanding of this fascinating creature. T-Rex's journey from ancient bones to cultural icon is a testament to the enduring appeal of dinosaurs and the power of scientific discovery. As we continue to unearth new fossils and apply cutting-edge research techniques, our understanding of T-Rex and its world will undoubtedly continue to grow and change. The story of T-Rex is far from over. It seems we've only begun to scratch the surface of what this prehistoric predator can teach us about life on ancient Earth. If you want to learn more about another prehistoric animal, check out this video. Until next time.